Hi, Mister.
Good evening.
How you do?
I'm fine. How are you?
I'm good, thanks. All right. Go on to some revision in the meantime. I'll just wait, of course, until my grace period for the others to join here.
Yeah. Okay.
All right. Cool. Mhm.
Good evening, sir.
Good afternoon, everyone. How are we doing today?
Good afternoon, sir.
What is happening today? It's 5:15 and it's only 8 of you here. Strange. This is the worst I've seen it. What is happening?
Prime Minister freedom of so then go enjoy themselves.
Serious? Or maybe that's what you were doing the last couple of weeks. Or
Me?
classes.
No,
Yeah?
you would have known what I was doing. I've been technical and tactical.
Oh, okay. I hear you, boss. No, but
Yes,
they have to be responsible with this opening up, sort quote unquote.
So,
I am such a slow learner, Ryan. Go ahead.
No, what I'm saying, we have seen this ploy before, which was
yes.
last year, right before the election.
All right.
And we didn't learn from it again.
Mm-hmm. So
yeah, I'm old because the local government elections due by February.
Right.
So it's the same thing we do again now. If you appease the people, and then the rates will go up and the place lock back down.
Oh yeah. And we have not learned. And the truth of the matter is, just watch and see. Just after Christmas, well, Christmas Day, Boxing Day are full lockdown days. But just after the Christmas season, into the New Year, all being well, you're going to see the spike in this COVID. It is going to be so alarming, and it's going to put more stress and strain on the health areas sector. It's bad.
All right.
Yeah, lockdown days.
Huh?
There are no lockdown days. Curfew hours different. No, there are no lockdown days.
No, but we could have swear them say it's a no movement day for Boxing Day and Christmas Day.
No, sir. Those days are not no movements. They are open now.
They're very open, sir. It's just the hours before Christmas Day and before New Year's Day. It's longer. But it's not a no next day.
Well, guess what now? Is it true? All of these days are no movement days because if I know for go on road, I stay in yard. Right about now, I'm gonna apologize. If you hear any distortions, because today, well, great news. The institution is going up for their institutional accreditation. So we've been in meetings from we've been in meetings from morning. It's an exciting moment for me. And I really became very tired and I tried to sleep and couldn't sleep. And then I say, you know what? Let me get up and come out of the house because I will fall asleep with my students today. So I'm outside lounging. So the heavy typing that I normally do. Be quiet, Ryan. The heavy typing that I normally do.
Poor people are lounging now, the rich people lounging now.
Well, I'll let you tell.
I got me this last day now.
I'll let you tell. No. If you go back and look at the definition of what lounging is, I did not say that I'm sitting on my stoop. I said that and a stoop is a staircase, like in foreign. No, I'm just sitting outside, kind of taking in some natural air.
You're not just sitting outside, you're lounging.
I know, that's what I'm saying. I'm lounging outside. I'm lounging. I'm trying to, savor the moment. Can you believe it though that we just have one more week before? Oh no. Excuse me? Somebody just said a while ago they can't wait?
Yeah, for the break, sir. Not that I don't love your class, sir, but
okay. No, well, to be honest with you, I felt that coming down on me one Monday, yesterday, the exams for your first certificate, we call it now, vetting sessions are started today. And what I'm happy for is that they put all the math courses on one day. So next week, Tuesday, I am going to be deadbeat. Say it again.
Is it going to be a 3 hours exam again?
I think it's going to be a 3-hour exam, but I will let you know more information as it gets closer. But I'm a little slow on something, and I'm a little slow on something, but I don't want to stir any. If I hear it's going to stir any intimate details, I'll just end the conversation. So I'm not a social media person. I've never been on Facebook. I have never been on we call it Instagram, nor Twitter, nor.
Sir, is not what I think you're going to ask, sir.
Okay, let me hear what we ask. No,
sir, is the combo thing you're going to talk about?
Yes, miss.
Yes. You know what, sir? The police, they reach before we reach my boss.
You serious? No, but
sir, never keep, sir. Never keep. The police reach before.
Let me tell you something. Call me slow. The only thing that I am on and is out of I don't want to say fastness, but I was curious because I heard some and for me, if you're talking to me about something and I don't know, and I feel cute to say, what do you mean, Charlene? What do you mean, Yannick? What do you mean, Ryan? I'll go and research it. So I went and researched TikTok. And then I said to myself, okay, let me create an account. And I created an account. And then after that, I got frustrated with TikTok. And then I came off. And then I said, you know what, let me go back on. And then I went back on. And then I am seeing this thing about this Kedisha, something. So me said, okay, fine. And me start posting myself and say, imagine, lockdown and then people have party. And I don't pay no man. And then I saw on TikTok where two guys were arrested. They're handcuffed together. And the guy said, so a KFC, you know, really there go? And I said, no, dog, you know, say, for real, a KFC, we never go, you know. And so I was like, so what is the significance? And then I was going to take up the phone and call someone and say, what is the significance of this thing? I don't pay no mind. And today I had the aha moment.
Sir, don't worry, I know you're alone, sir, because up to last night, me still never know what did I go on, sir.
Sir, I don't
listen to me.
Party, and the thing is, I don't really want to know because I saw on the start headline as of the combo party saying that they're not prostitutes, so therefore I was okay. I don't want to know what the combo party is from them.
No.
There's only one direction in which data go. So
no. Hold up. The thing about it, you know, is that I kind of self-discovered the acronym KFC. That's what I'm talking about, you know.
Oh, there's an acronym to it that is not Kentucky Fried Chicken.
Okay, so I self-discovered the KFC that is not Kentucky Fried Chicken.
Oh, sir, you know more than me, because I never know that part there.
So this is why. It was self-discovered. So when them talking about this KFC, I was like, what is the significance with KFC? What is the significance? But anyhow, I'm just saying, you know, guys, I am here in my little neck of the woods, sitting and wondering when this COVID going free up so we can go off foreign and go enjoy myself. And, you know, I really look forward to at the end of the school year and normally teach summer school. And it has been a staple in my diet for many years that I take a little 2 weeks vacation round about the start of August or the middle of August in preparation for the new school year. I have not done this since 2019. And I'm not lying to you. It like when I started off with you guys in September, I had absolutely no break because I just moved from.
Sir, you know, sir, where that is concerned, boy, I'm really feel the school do we are injustice, you know, and we can't stop that about,
I agree.
Because they knew that the CSE results were not going to come out. So they could have given us at least a week.
Okay.
I know we are being. You understand me, sir? They knew.
Okay, let me respond to that. Because the truth of the matter is when the college is at fault, I am the first one to say, students, I agree with you. But I'm going to explain what happened. I was in a meeting in July, because we had a lot of conferences, you know, online conferences. And I remember a meeting was called in July with a select group of us from the college who would look at the way forward. Now, when CXE came out to say that the results would come out a little late, we met and we said, you know, if the results are coming out late, I think we should delay school. But when they went to the CCCJ meetings, The other community colleges says, no, we're sorry. Excelsior wants an extension, a delay to the start of the school year. No, we want to start the school year because last year when we did that, the students who would normally come to the community college, they went to UB and UTech and IUC and UCC and all of these other universities, and the community college lost some potential students. That too was plausible because I know that too was true. And then when we had our meeting in July, I was the one who, I remember saying to them that, pre-calculus is going to take a hit because the first year students who come in with CSET mathematics will normally give them pre-calculus to do XYZ. You think it's only students? There are some lecturers who barely have any students to teach in a class. You see that said pre-calculus group? I have either 10 or 11 students in the class. Normally when I'm teaching pre-calculus, 20 or 30 odd students, almost 40 students I have. And it's 10 students, and of the 10 or 11 students, it's one student that has an ID number of 2011. I know how come I get that one student with ID number of 2011. Student did exam long time and just decided to come to college. I don't have a new student from CSEC who came in now, right? And when we recognize that CXC changed the date of publishing their exam results, citing the volcano in St. Vincent and the Grenadines and et cetera, and Barbados got this and that and rate 80, and the results came out late October, we had to go back to CCCJ and say to them, I said, listen, because we can't make any moves without CCCJ because they are the secretariat, they are the governing body. And a meeting was called, and guess what? It was at that time when the meeting was called, these other community colleges who were so blindsided of the fact that it was going to cause a ripple effect, only now recognize what Excelsior was talking about long before in the summer. So the decision came, and that boy, as a matter of fact, is whilst I was teaching you earlier on in the semester, the decision came out to postpone the exams for December and put them in January. So the truth of the matter is, Ryan and others, I too am feeling a little bit away because we could have used about 3 weeks out of September and just relax and just get rejuvenated. And now the semester is extended. So come January, I have to come back to you. Not that it's a problem coming back to you now, but it is rough. What has happened to me on a Monday and Friday, because the results came out so late. I'm teaching a Cape math class on a Monday and Friday evening from 5:30 to 8:30. I don't have time. Every evening I'm there teaching. I don't have time for myself. It is just rough. I mean, up to recently, as 2 weeks ago, I had to change the timetable for 1, 2, 3, 4, 5 of my lecturers. And they're complaining. I said, guys, the students them don't turn out for class. I mean, the students them don't turn out. So Ryan, I agree with you. Charlene, I agree with you. Others, I agree with you. Yannick, yes, I heard you. But guess what? This time I can tell you that Excelsior was not at fault. We can tell it straight up. I mean, when I'm at fault in a meeting and I say, yeah, them at fault for true. But that 1 year, I can't blame them. They're really not at fault. But it is what it is. So what I'm gonna ask you to do though is, I was supposed to look for something for you guys. I prepared a voiceover in the summer semester when I was teaching business calculus of some integration, something. And I know 1 or 2 of you maybe, we call it now, 1 or 2 maybe be lagging behind in that regard. And I said I was going to look for it and repost it. So at least you can have it. It's about a 45-minute video. So I'm going to look at it and see if I can repost it tonight. But in all of this, I know we have 1 week, 1 full week left. Well, 1 full week and a class left. Next week Tuesday is going to be. I don't even know how next week Tuesday is going to work out, because I know I have an all-day vetting session online. And next week Thursday, there's something next week Thursday. Anyhow, I can't remember right now. But all I'm going to say to you, you guys have been doing very well. Some more than others. And I'm going to ask that, in the Christmas break, you try as best as possible to get
Drink a
some
lot
work
of
done.
rum.
Oh, Jesus, bless the Lord. Kelvita's not here. Kelvita's not here, so you won't get any encouragement from that. All right. So with that said, there are two areas that I need to go through so that I can finish off integration tonight. And it's two small areas. One of them is a little longer than the other. I can use about 20 minutes, 30 minutes at most to finish off one, and then we spend a little bit of time doing the other.
Sir,
Yes, sir.
Is integration the last topic?
No. So after this topic, unit 4, I'm going to have applications of integration and differentiation that I'm going to be doing come Thursday and next week. So I'll finish those and then I should be able to start the final topic. I have one more area to look at, which is the exponential something topic. That's where we're going to go to the L'Hopital's rule, and then that will be it. So come January, all being well, I will just wrap up that final unit, which is really not a long unit. That final unit involves a lot of first order differential equations. And I know in the past, they set a lot of questions on those on the exam. So I just need to, what I really want to do is to touch on that. So at least you can use a Christmas break, when you finish drinking a little white rum, your sorrel, that is, with a little bit of Jesus in there, you can, look over one or two of those. I am not worried about your readiness for the exam, because we'll have enough time to just do a quick review for the next 3 weeks in January before you're sitting on the exam. So I'm not worried about that. I just want to make sure, I don't want to leave too much. In January, I want to cover as many areas so that you have a lot of work to do in terms of your preparation. All right?
Sir, question.
Go ahead, Papa.
For the EDICASOF, when is the cutoff point?
The system says December, but I'm getting a lot of requests. I will extend it into the new year, God's willing. So you don't have to worry about that part. Just make sure that you complete it.
Yes, sir.
All right. The final thing before I move into what it is that I was supposed to be doing something in the meantime when I'm talking. The final thing that I'm supposed to, I'll talk about before we move into the actual teaching tonight is that I'm actually using my tablet. I think I told you that before. So the heavy typing that I normally do, and the stuff that I normally we'll call it adjustments to the document support and so on, I may not be able to do it unless I go back inside. But I don't think I need to, because I think I prepared enough, and it is self-explanatory. I'll make a notation of it, and should in case it's something that I need to do, I will definitely go back and adjust those for you. Okay, so with that said, we're looking at integration. I am pretty pleased for the level of work that is coming out. Some of you need to work a little bit harder in understanding what is expected of you. In understanding what is expected of you. But outside of that, I don't think I really need to. Oh Lord, help me. Really need to be worried per se. But just to get you guys ready enough for what is to come. All right, so I'm trying to share the document. Oh, come on. You're not seeing it, right? Are you?
No, sir.
What is that? Okay. Zoom and appear on how the function allows you to. Not sure. But it says that I'm sharing it. You're not seeing nothing at all?
I'm seeing it now, sir.
Oh.
Seeing what, sir? Your screen?
Yeah. Are you seeing the screen that says integration?
Yeah, I'm
Yes,
seeing.
sir.
Okay. Okay. Because I was a little concerned that I may have to just get out of my lounging state, Mr. Ryan, to go back inside. All right. Let's
But
go.
sir, it is small though.
No problem. I can bigify it easy. That's not a problem. I just want to find where it is that I want to go to. All right. Can you see better now?
Yes, sir.
Nice. All right. So we're looking at the integration of the exponential functions. The integration of the exponential functions. To be honest, really not difficult. I'm giving you only two rules. Only two rules. And only two rules for you to remember. And I'm going to spend a good 5-10 minutes out of those two rules. I mean, out of the time that I have allocated for this topic. And then we spend another 20 minutes to work some questions. So, rule one, look at it. It says the integral of the exponential function raised to a power dx. The integral, let me see if I can find me. Oh, Lord. All right. Don't want to disturb that. The integration of the exponential function raised to a power ax dx is going to be, and I want you to work with me. I want you to work with me. So it's going to be 1 over, you see that A in blue? Where do you think that A comes from?
The power, sir.
What about the power? What did I do with the power to get that?
What's the word
differentiate.
again?
Say differentiate.
Differentiate, sir.
Right. So when I differentiate ax, what do I get with respect to x? I get a. So I'm going to reciprocate that a to get 1 over a. So I'm trying to find my pointer on this. It's not going to happen because a third party thing. It won't happen. Right. So when I differentiate ax, I'm going to get a. When I differentiate ax, I'm going to get a. And that a is going to be reciprocated, and it's going to go into the denominator. So I'm going to have 1 over a. So 1 over a is the differentiation of the power. Then you're going to see ln e. Look at the base. Are you seeing the base? The base is e. Can you see that?
Yes, sir.
Good. It's going to be ln of the base. It's going to be ln of the base. Ln of the base. So what you have as a fraction there is going to be 1 over a ln e. The a is from the differential of the function. And ln e comes from the logarithm, the ln of the base. Whatever the base is going to be ln of that. And then do you recognize that I write back my exponential function plus c, e to the ax plus c? Anybody, somebody?
Yes, sir.
All right, so I'm taking it in stages. As I said before, I'm not rushing the definition. I want to see all parts of the integration. I'm sorry here. So what you need to recognize is the differential of the exponential function is the exponential function itself. The integration of the exponential function is the exponential function itself. So when I differentiate or integrate the exponential function, my result will contain the exponential function itself, but of course, some other little things that we will do, right? For differentiation, it means that we're going to differentiate the function and put it as a multiple. For integration, we're still differentiating the function, but we are going to reciprocate what it is that we would have differentiated. All right, so let's go. So the integral of e raised to the ax of dx, it means that I'm going to differentiate the power. When I differentiate the power ax, I'm going to get a. And of course, I'm differentiating with respect to x, I'm going to get a. Now, when I differentiate and get my a, I'm not going to put an a there. I'm going to reciprocate. So it's going to be 1 over a. But because I'm integrating the exponential function, I will now have to find ln of the base. ln of the base. Oh, sir, but the base there is e. Very good. Base raised to a power. So you know what the base is, you know what the power is. So it's going to be 1 over a ln e times the exponential function. And because it's an indefinite integral, you're going to have your plus c. So what that works out to be, in this case, ln e is equals to 1 every single time. ln e is equals to 1. So all of what you have there in blue is now reduced to 1 over a e to the ax plus c. 1 over a. The second pink line that I have there, I wish I could touch it because and point it, but forgive me, the device does not allow me to do that. After the square brackets, what I did was just to rewrite the question. Rewrite the question to say the integral of e to the ax dx is simply going to be, I should put that in another line, is simply going to be 1 over a e to the ax plus c. So why? Because ln e is equals to 1. So once I'm integrating the exponential function e to something, because I have to find ln of e, but ln e is always 1, all I have to do is to differentiate the power, reciprocate it, write back the exponential function, and put plus c. Done. Question. Anybody don't understand when we talk about a while ago?
Me, sir.
Okay, but you're not seeing.
The whole light go right over my head. All right, so I think the color code kind of confusing me because I was using that to kind of try and track the progression.
Hold on 1 minute here, Peter. Hold on. 1 minute here, please. Sorry about that. 1 minute. Hold on. Hello, I'm back. Sorry, somebody was asking a question. Go ahead, please.
Yes, sir. I was saying that I was trying to use the color coding to follow, but sir was seeing everything on your screen.
When you say everything, what you mean? Oh, no, that's fine. That's fine. That's fine. I don't have nothing to hide.
Just to make sure you understand the next thing, you know, look a secret life, but
Life is an open book.
so what I was saying, I was following the color code to kind of track the progression of it. But when you went back to pink after the blue, I'm kind of confused as to what it is now.
Okay, all right. And you see, I just touched it a while ago, and the software that I use, I did everything in one, or so I split it just now, and I'm unable to split. So I can go through again. Not a problem. Not a problem. Not a problem. So what I'm saying to you is the integral, and you're all seeing the screen, right?
Yes, sir.
Okay. The integral of e to the ax dx, which is the first rule that I'm looking at. E to the ax dx. When I'm integrating the exponential function e raised to a power, I am going to differentiate the power and then reciprocate it. When I differentiate the power, what do I get?
A.
And when I reciprocate it, what do I get?
1 over A.
1 over A, very good. Can you identify the 1 over A in blue yet?
Yes, sir.
Okay, good. Very nice. And also, it means now that I need to find ln, the reciprocal of ln E. It means that when I say reciprocal of ln E, it means that ln E is also going to be in the denominator. All right? So I have to find ln of E. But if you look to the far right in that line, you recognize that ln E is 1 every single time. And then I'm going to write back the exponential function. I'm going to write back the exponential function, which is going to be e raised to the ax. E raised to the ax. And then plus c, because I'm talking about an indefinite integral. All right, so what I'm having there is 1 over a ln e times e to the ax plus c. But because ln e is equals to 1, that is going to be reduced to 1 over a e to the ax plus c. You see that third, you see after the square brackets, and you're seeing that the integral of a to the dx?
Yeah, that should have been in the next.
Say it again?
That should have been in our next line.
It should be the next line, or I'm going to delete it. So when I go back inside, I'm going to delete that part, just to show you that the one in blue is the middle ground, and then the last piece, 1 over a to the ax plus c, is the final result. So I will, you know, I when I'm looking at it, I can actually take it out. So I will remove it for you guys. All right, so I will remove it when I'm sending the document. Normally, I would remove it now, but because as I told you of my location. All right. So, are you seeing the rule a little better now?
Yeah, is the all rewriting of that was confusing me.
Right. So what I'm saying to you now, so if I ask you the integral of e raised to the ax plus c, it's really 1 over a e to the ax plus c. So where do a come from? It's a differential of ax. So whatever the power is, that's what I'm going to differentiate. And I guarantee you, when I start giving you the examples, you will see more of what it is that I'm doing. All right? Are there any other questions, number 1? All right. Let me look at number 2. Number 2 follows the same vein. Number 1 and number 2 are exactly the same, except that the base in number 2 is not the exponential function. The base in number 2 is not the exponential function e. It's a number. So look at number 2. Number 2, so I say differentiate the function, then reciprocate it times the given exponential function plus c. And then number 2 says the integral of a raised to the bx of dx. Similar to what it is that we did up top. I'm going to differentiate the power. And in differentiating the power bx with respect to x, I'm going to have b. I'm going to reciprocate it, so we have 1 over b. But also, I'm going to find ln a. Oh, sir, just like we found ln e, yeah, man, I'm going to find ln of the base. I'm finding ln of the base. So whatever the base is, I'm finding ln of it. And then I'm going to write back the original question, a raised to the bx plus c. So you'll recognize that number 1 and number 2 are really saying the same thing. The difference with number 1 and number 2 is that number 1, the base is an exponential, is the exponential function e. And number 2, the base is a natural number, except for the number 1. Let me ask you, why can it not be equals to 1? Why a cannot be equals to 1?
Because it's not the exponential function.
Look again. Why can I not have ln 1?
You're going equal to 0.
Very good. ln 1 is equal to 0. ln 1 is equal to 0. All right. So the only condition there is that ln cannot be equals to 1. Sorry, a cannot be equals to 1 because ln of 1 is equals to 0. All right. So you're going to differentiate the function, take ln of the base, then reciprocate both of them, and finally times it by the given exponential function plus c. Look at that. Look at it. Tell me if you agree with it. I will not talk. Just ask me the question for 1 or 2. Then I'm going to have some questions and you're going to say, oh, easy something come out to be.
Oh, sir, so that is why you put the ln e up there, even though it will be equal to 1. So that we
Very good. Absolutely. 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 So you know how I teach now, because I don't want to have 2 different rules. I want to have the same rule, but in having the same rule, you can actually my God.
in party that I start.
Excuse you? Oh, Jesus. Oh, Lord, I tell you. And with my look, trust me, it would have happened the same time when me outside lounging for my class. Yeah, so, but I'm Mr. Sean, sit down right there, so. Yeah, you couldn't tell them otherwise, All right. So this is what it is. So, yes, Yannick, and I'm happy that you recognize it. The only reason I have that in blue in the first one is to show you that the ln e, I'm taking ln of the base. Because you can say, sir, how you take ln of this one, you never take ln of the other one? Yeah, man, we take ln. So the rule really is you're going to differentiate the function, take ln of the base, and then you're going to reciprocate both of them. Reciprocate the differential of the function and reciprocate ln of the base, and then times it by the given exponential function. That's all that there is to it. Let me say it again. You're going to take ln of the base. You're going to differentiate the function, and then you're going to reciprocate both of them. But both, sir, you're going to differentiate the power, then you're going to take ln of the base, then those 2 things, the differential of the power and ln of the base, you're going to reciprocate it. Oh, I see it now, sir. That's how you get the 1 over b times ln a. And then you're going to times it by the given exponential function, meaning the same function where you start off with a raised to the bx plus c, because it's a definite integral. It's an indefinite integral, I'm sorry. But there's a condition for this one, that the value of a cannot be equals to 1. Why again, sir? Because anything ln of 1 is going to be equal to 0. ln of 1 is going to be equal to 0. So it cannot be equals to ln a. for ln a cannot be equals to 1. All right? So when I'm differentiating an when I'm integrating, I'm sorry, I keep saying differentiating, but when I'm integrating an exponential function, it's going to be, I'm going to differentiate the power, put it down, then I'm going to find ln of the base, put it down, and then I'm going to reciprocate the pair of them times the exponential function itself. All right, I think I said enough of that. Let us look at this one here. The integral of e to the 2x dx. The integral of e to the 2x dx. We know, say, the base at e. So when we find ln e, we're going to get what?
1.
We're going to get 1. So all we're going to do, so once you see the base being e, we're not going to bother write that because I'm more writing for do. And you need to say, but sir, you know, no, say ln e I want already, so we're going to be saying that. Me agree. So once you can recognize it, and that's why I have that the first rule, that little middle piece there in blue. Once you recognize that the question, the integral, is e raised to something, you know, say ln e is 1. So all you have to do is just differentiate the power, reciprocate it, and write by the exponential. So watch this now. E to the 2x simply going to be a half e to the 2x plus c. Talk truth.
Yes, sir.
Is there someone in the class that don't say that?
Sir, just go over it one more time.
All right, tell me what it is that you're not seeing. Talk to me now. Tell me what you're not seeing.
Don't worry, sir. Don't worry. See it now.
No, me not believe you. Me not believe you. Me not believe you. Me go over it, you know, but me not believe you. You not see it, but you don't want to tell me when you not see because you still not see it. I don't know what to say. I don't want nobody go say, you should not see that. So me going to do it. Me go do it. But what I wanted you to tell me though is what it is that you're not getting, but I will do it. Me in the classroom way too long now for know the sweps. So what I'm saying to you is e, the integral of the exponential function e to the 2x dx. The integral of e to the 2x dx. The integral of e to the 2x dx. Once it is that we have the exponential function e, we can skip a step. What step, sir? We're going to skip the step to write down ln e. Why skip that step? Because ln e is equals to 1. So whenever the base is e, what you're going to do is to differentiate the power. And when I differentiate the power, 2x, I'm going to get 2. Then I'm going to reciprocate that. So instead of writing 2, I'm going to write 1 over 2. And then I'm going to write the exponential function back, plus c. So the integral of e to the 2x plus c is going to be equals to 1/2 e to the 2x plus c. Let me ask you a question. What if I ask you to integrate e to the 5x plus dx? What would you get?
Repeat.
1/5
E to the 5x dx.
1/5 e to the 5x plus c.
Simple. How many marks do you think you'll get for a question like this?
20.
1 more.
You know, I was expecting that 20 mark, you know. But guess what? I kind of a little disappointed in you because I thought you were going to say 30 marks. I
No,
thought you were going to say.
I'm not going to give away so much.
Well, guess what? Whoever said 1 mark, I will give you 1 more mark because that would be the correct answer. That would be the correct answer. So yes, it's just a 1 mark.
Putting them get a whole heap of marks, or what kind of man game?
So you can go on here, Miss Yan. A 1 mark they might give you. Not 1 more over the 1 mark. 1 mark. All right. So now, having gotten our 1 mark, Yeah, that the man I'm gonna do. The man I'm going to. I don't want to switch it. I don't want to switch it. I want to just start. Yeah, so the man I'm going to use, more likely, these are the questions that you may get on a multiple choice. That's the point I'm making. The questions like these, you may get on a multiple choice. All right. So there are only 14 students in class tonight. 13 actually. And anyhow, so let's go again. Let's go again. So when we're integrating the exponential function, remember the exponential function. There are two types of exponential function, you know. One where the base is e, and the other one where the base is not e. Because number 2 is also an exponential function, you know. 2 is also an exponential function, except that the base is not e. All right. So in the first one, where you have e to the bx, sorry, a to the bx dx, you're going to differentiate the power. Differential of bx is going to be b. So it's going to, and then you're going to reciprocate it. So you're going to have 1 over b. You're also going to reciprocate ln of the base. But in this case, it's going to be ln a. So what you'll have is 1 over b ln a times the exponential function itself, which is e to the bx. Now, as opposed to the first example, ln a cannot be equals to 1. Because if a is equals to 1, we get 0 because ln of 1 is 0. And it means that we will not have a function to start off with in any event. All right, that's the only condition. In the other case, we know that ln e is equals to 1. So that one there is reduced. All right, so very good, very, very good. Now, look at this function. E to the x squared 5x plus 5x plus 2. What do you think that answer is?
That with you know, sir.
Yannick, don't say nothing more. No man, Yan. Guess what? It no bad man. Remember what sir saying, no, differentiate the power. When you differentiate the power, Yan, we get.
Alright, so I'm going to get. Well, I'm going to write it on paper and then answer you, sir. I'm going to get it like the other one.
Then you differentiate the power and to get you writing down that you're supposed to do it out of your head.
Alright, so I'm going to try to think out of my head. So I get 1 over 2x plus 5. That's the reciprocated value, and then I have the exponential function back plus c.
Duh.
Yes, Yannick.
Yeah, duh. Yeah. Yeah, man, that's it. Nestor, you following me?
Sir?
You following? Nestor,
Yes, sir.
what
Sir,
happened?
I'm telling you the honest truth.
Mm-hmm.
Sir, what me do, sir? Come in and get it when you teach sometime. Like when I have to do, I go through the recording again. Because it not connect when I teach it the first time.
And that's fine.
You mean, sir?
Yeah, accessible. All right, that's fine. All right, so and Nestor, I hate when I talk to you and you sound like the world is on top of your head.
Sir, I'm telling you the truth, sir. It's not just me, but everything against me. I swear. Everyone me tell you a problem. It's a horrible year for me.
No, guess what? No, guess what? I'm going to shake it off here because we're not going to carry this into the new year.
Amen.
And you know what you need to start doing, Yanni? Even though it's a horrible year, you're going to speak it. There's life and death in the power of the tongue. Sorry, I keep saying Yanni. Nesta. Trouble now. Trouble. Trouble. Trouble.
In an accident, the one.
Jeez and peas. No, all me reaching at this.
Oh my Lord, trouble. You see? Anyway, yes, Nesta. There are times when we come across some very difficult courses and difficult things in life, but we're going to speak positivity through it. All we know say, I will be able to pay my mortgage this month end. I'll be able to fix the car. I'll be able to pass this course. You have to speak it into being, because if you sit in the sorrow, oh Jesus, when I have no, where am I going to get money from? And then you're going to send up your blood pressure. Then you're going to get depressed. The people in my work, we know your business got to, because in Nesta go through problems, and Yanika go through problems, and you have to go stop and get explanation. I want to you. And then you can put yourself to tell a lie because you don't want everybody know your business. You say, no, man, I'm fine, man. Deep down, you know, say you're not fine. All right? So, and don't worry about it. I'm going to tell you something if it makes you feel a little bit better. So, when I was going to school, I had some very bright people around me. When I say bright people, I mean, even if I did not want to study, I had to study. Because when them come class, they make me feel, them tell me something not bright. They don't tell me directly. You know, like sometimes them say, show me a picture to say that you live in Portmore without saying that you live in Portmore. And since when they put up, say them have on 3 fan on, and you know say Portmore, then you got Portmore at. Yeah, man. Don't have to tell me say me not bright. And sometimes when the teacher teach, you know, Nestor, I'm like you, with the affair, me I hear what teacher say, you know. But when the teacher say one word, they must finish the sentence with the teacher, and the teacher say, yes, man, very good. And I say, but oh, me can't do them something there. And I know that it's not that they're repeating the course because me and them have come up from all long in a school. But they're not them going extra class, that's not my concern, but why me can't get it the first time? And I went tell you, I remember one such night I said to myself, I felt really bad in one class. And I say, hey, watch this, man. And I went home and I started studying my math, literally started studying. And I started getting on top of things. And I started working ahead of my teacher because I had a copy of the syllabus pasted in the front of my notebook. And this was GCE that we were doing. We never do CAPE, we do A-levels. So A-levels would send you one thing, and normally them for them outline like all 2 pages, right? Nicely set out. So I know what the teacher was going to moving on to next. So I used to read my textbook and prepare before the class. So when my friend them in the class don't start talking, somebody say, hey, watch this now. So me start talk too. And everybody say, you got extra class? No, I don't. I just started doing my schoolwork. Them say, oh, and then the competition started to rise because them recognize and them alone understand. Somebody is another class that understand. What's the point I'm making? The point I'm making is, yes, you may need a little bit more time than somebody in the class that sees it at the go. But what you have to make sure that you are doing is that you're on top of every single thing else. Because if not, when it's time to prepare for exam, you're going to have way too much and you're going to get flustered. And that is going to be the end of it. All right? But in as much as how you may have a difficulty following what is happening in class, when I'm doing it, I'm going to ask that you just maintain that positive attitude. Because if you have that negative attitude, it's going to take much more out of you to try and understand what it is that I'm doing when you rewatch the videos. All right. So let's go again. Go ahead, Sonny. No, go ahead, hon.
Say that I have a negative attitude in us.
Mm-hmm.
It's just that, sir, if I feel like if I was negative, I wouldn't come this far.
Mm-hmm.
But it's kind of discouraging when I try to understand.
Yeah. All right. Next time I'm going to ask again. And guess what? This is not an attack on you because you are a bright girl. And I'm speaking things into your life now. But I want somebody else in the class. And maybe they don't want to do it because are your friend and they don't want to tell you. But you see the way in which you're even speaking, sir? It's not a negative attitude, you know. It's that in itself. So I don't know if anybody hear that, but that in itself so negative. Anybody can agree with me?
All right, mega change that, sir. Mega
Yeah,
talk
man.
positive and you
Yeah,
know,
man. Yeah, man. So
mega
just the
claim a
way,
blessing. All right.
absolutely, just the way you is just the way you say it, you know. Um, and we are adults. We are adults. Um, we are adults, and I mean, if it means that I have to stop to encourage somebody, it is my responsibility. The other night I was teaching a class, and I said, "Good evening, guys. Normally, you will know. Normally, you will come in and you'll see me log on. Now, once I log on, and I'm the only one there, I'm sometimes seated around the computer and I'm, doing my final touching up on my notes. If when I log on and I see other students in the class waiting on me, I will say, hey, Nesta, how you doing? Like I did today, Nesta, when you were alone, you're the first one to log on. I said, Nesta, how are you? I'm fine, sir. All right. I'm just, as per usual, I'm waiting 15 minutes for the students to come in, right? And sometimes you guys will come on and see me and say, hey, sir, walk on. And I remember some weeks ago, somebody came on and, hi, sir, good evening. And I said, no. I said, no, so that student in normally sound. And then we had a little conversation. And I'm going to tell you, and I'm going to tell you, I'm not telling you what the student and I discussed. I'm going to tell you my business. So I was going through a little thing. And I said to Father God, I said, God, say, a Christmas will come, I have this to deal with and that to deal with. I need some dough. And out of the blues, somebody that owed me, out of the blues, I mean, I did not expect it. 1 ounce. Come and say, hey, that I just funded the account. I say, yeah, man, all right, cool, thanks. I couldn't even check it immediately because I was so busy doing some other stuff. And when I looked, I said, okay, God, thank you, because at least this can take care of some of the immediate things that I was praying about. What's the point I'm making? You see, when you have problem, and then you say, not worry about the problem, it not change the problem. I don't know if it works for anybody when you worry about the problem. If it's you have to proactively deal with the issue, not worry about it, deal with the issue so that you can overcome. So it's just me interacting with you guys over the period of time and know how the normally sound. My little friend Kels wasn't well. And then she come class, say something was wrong. I know something was wrong because she wasn't being, matter of fact, how was she there? I know something was wrong. So and I mean, I have come to class already. Hi, sir, how are you? I'm fine. No, sir. Something wrong with you, sir. What is the problem? I said, no, I'm good. He said, sir, that's not how you normally sound. Because it's a relationship that we're having and you recognize that something is off. So, it's just for us to encourage each other as we go through this sojourn. And Nestor, you're going to be fine. Just do what it is that you need to do. And if it is that you're having a difficulty, reach out to me, reach out to your classmates, because we're in this fight together. One of the things I can tell you is that Exeter Community College CCCJ has a whole heap of paper. They're not short of paper to print your degree. They have one heap of paper. So we're not in a competition to see who can get this over, who can get that. No, we have enough paper. So I'm going to encourage you to speak up and to work up, right? But trust me sitting behind this microphone, I'm discerning when I hear how you guys respond to me. I'm discerning things, right? So I want you to be able to focus. Anyway, let's go. All right. So it's not bad. And yes, Yannick, I heard it too, Charlene. You see, all you have to do is to differentiate the function. Differentiate the function, and when you differentiate the function, you reciprocate.
Not seeing a screen, if you're sure.
You're not seeing the screen, none of you?
No.
No,
Oh
sir.
dear. Oh dear. Hold on. Zoom. Oh yes, I'm not seeing it for true because start no. And then no. Oh Lord Jesus, help me. Tell me that you've seen it now.
Like sir, another one. So.
I'm very much home.
No, Sasha is lounging.
I'm lounging outside, Sasha Boo. I'm lounging outside.
I see you.
Yeah, man, and you can hear my neighbor's little mongrel dog. But anyhow, are you seeing the screen now?
Sir, just to confirm. So for rule 1, you're saying that the base will always be E, and for the second rule, the base can be anything basically then.
Very good. But before I even go any further and explain on that, are you seeing the screen?
Yes, sir.
Yes, sir.
Okay, great. Yes. Is this next done?
Yes, sir.
Yes, sir. So once it is that you're given an exponential, so the exponential function can be of two forms. It can be of form 1, where the base is E, as in egg, or you can have the exponential form where it is a number. If the form is E, as in egg, you know that ln E is equals to 1. So all that you're going to be doing for that integral, keep saying differential, but for that integral, you're just going to reciprocate the differential and write back the function. Let us look at an example. Example number 1. You recognize that the base is E. So when you find ln of that base, you're going to get 1. So there's no need for me to write ln of anything. I'm just going to differentiate the power and then reciprocate it and then write by the original function. Watch me. When I differentiate 2x, I'm going to get 2. I'm going to reciprocate it. I'm going to get 1/2. Then I write back the function e to the 2x. You see that next one?
Yes, sir. I kind of get it now. Because
all right.
Reason out it myself.
Sir, I am begging you. Go over the number 1 again.
All right. So the number 1 I'm saying to you, e to the ax. When my exponential function can be of two forms, where the base is e, that's form 1, and form 2, where the base is a number. Where the base is e, or where the base is a number. When the base is e, you're going to differentiate the power, reciprocate the power, times by the original question, the original function. For example, e to the 2x, I'm going to differentiate the power 2x. I'm going to get 2. I'm going to reciprocate that. I'm going to get 1/2. And then I'm going to write e to the 2x plus c. Let's go again.
Okay.
Next. E to the x squared plus 5x plus 2. Yannick said, I think them have a problem with sir, no? We get a simple one, and then sir little to 6. And then she recognized, but hold on there. He might try to trick me, but me get it. Because the differential of x squared plus 5x plus 2 is simply 2x plus 5. Okay, sir, easy 1, 2, 3. We're just going to, when we differentiate that, we're just going to reciprocate it. When we reciprocate it, we're going to get 1 over 2x plus 5. Then you're going to write back the e to the x squared plus 5x plus 2. Done, plus c. You see that?
Yes, sir.
All right, do me a favor now.
I'm seeing in the up top where you say A. So because it's x, you would put the 2 before the x, reduce the power.
Yeah, man, you're differentiating, you know. Hello, I'm Sasha Bo. Yeah, man, you're differentiating, you know. When you differentiate, remember, say you reduce it by 1.
Oh.
Yeah, man, you're differentiating. Don't tell me say forget differentiation and such.
No, sir.
Okay. So you're differentiating. In the second example, though, you see that the base is not e. The base is not e. It's something other than e. So now we have to, again, just like the first one, differentiate the power. When we differentiate the power, we're going to reciprocate it. But now because the base is not e, we have to find ln of the base. Then, sir, why never find ln of the base with e? We did. But we know that ln of e is equals to 1. So because it's e, we don't have to write that extra step because we know ln e is 1. Then, sir, let me ask you a question. what if you go into a multiple choice test and they ask you to integrate, for argument's sake, e to the 2x dx, and I wrote, and in the answer I'm seeing, I wrote as my answer rather 1 over 2 ln e times e to the 2x plus c. Sir, will I be incorrect? Well, you answer me. Will you be incorrect?
No, sir. Technically,
You
same.
wouldn't. Absolutely, because ln e is 1. So you won't be incorrect. And guess what? Don't be surprised if if you get a multiple choice test and them have the ln e inside there, so too. It's ln e is just 1, so it really doesn't matter. So whether or not you have it, it really doesn't matter. It really doesn't matter. All right? So I'm going to give you one to do. Now, the aim of me preparing this, remember, Sasha, what question I just asked you a while ago, Sasha?
Repeat that, sir.
What question I just asked you a while ago, if you remember? What's the last question I asked you?
What you would find in a multiple choice?
That I asked you. Remember I asked you a while ago if you forget how to differentiate?
Yeah.
All right, okay. So, because I want to keep the differentiation alive, watch my other question to you. E to the x plus 1. No, x minus 1 over x plus 1. Let me big effect because we don't want Sasha to go for your glasses.
Turn my face in the monitor.
All right. Can you see it bigger now?
Good, sir.
So number 3,
right.
sir.
Number 3. What are you going to do, Lexon? No, Lexon, tell me what's the first thing you're going to do?
That look like you have to differentiate that. That would have be the quotient rule.
Very good, Lexon. Very good. All right. I'm going to give you a couple of minutes to do that for me. Yes. Go ahead and differentiate for the quotient rule, please. Very nice. All of you, that is, not just Lexon, all of you. Where is Elvita? Where is my Smiths? And where is, oh Lord, what's your name again? Goodness. Mosquito, go away. Oh, sorry, Charlene, I just see it. Somebody just sent me something a while ago to say that. So actually, they actually revised the times. You're correct, guys. Christmas Eve curfew commences 1 a.m. That means I can do a road up until 12:30. And Same thing for New Year's. Oh Lord. Poor thing was. When you're finished, just let me know, please. None of you should complain about not able to do this question because what you're doing is differentiating x minus 1 over x plus 1. Quotient rule. Oh, Jesus, Sean, you actually speak to me in class. Today's a fabulous day. Can you give me an answer, Sean?
Sarah, I have x minus 1 over x plus 1 plus c. Oh, I did it wrong then.
No.
I did it wrong. I did it wrong. Yeah, I did it wrong.
Hold on. So I actually work out this one, but you know what I recognize? Crap. I'm actually using a Microsoft Word document. I should have actually PDF the document so you can see my brackets. Remember when you're differentiating, Sean, you're going to square the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. So remember, when you differentiate the function, you're going to get 2 over x plus 1 all squares. All right, because I'm using a Microsoft Word document, you're not seeing my x plus 1 in parentheses. I actually have the x plus 1 in parentheses. All right, so you're not seeing it. So let me see if I can do something with my phone to do this stuff. All right, go on to the stuff for me, please. Rework the thing for me, Sean. The quotient rule. Let me see if I can PDF the document from my banger outside here. Let me stop sharing for a moment, please. I see my screen. All right, so I just PDF the document. All right, so I just PDF the document. So now you're seeing my parentheses that wasn't coming up in the Microsoft Word aspect. So let me just refresh your memory here with the differentiation. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. So the denominator is x plus 1, so I write it back. And then you see my dot, which means that I'm multiplying. Forgive me, I'm unable to spotlight because of the device that I'm using. And times the differentiation of the numerator. When I differentiate the numerator, minus 1 is a constant, it goes to 0. But when I differentiate x, I get 1. So that's why I have that times 1. And then minus the numerator is x minus 1, so it's going to be minus x minus 1. And then times the differentiation of the denominator. When I differentiate the denominator, I'm going to get 1. So it's times 1. And then it's all over the denominator squares. So I'm going to have that 1. Work with me. That 1 outside the parentheses, when I multiply through everything inside the brackets, I'm going to get x plus 1. And that 1, I'm putting in front of the negative sign to say negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. And you recognize now that I have a positive x and a negative x, and they're able to cancel out. And you recognize that I have a positive 1 plus another 1. So I'm going to have 2 over x plus 1 all squares because it's over the denominator squares. So that is my differentiation. But remember, the rule says that we can differentiate the power and then reciprocate it. When we reciprocate something, it means that it's flipped. So the reciprocal of 2 over x plus 1 all squares. Then I flip that, I'm going to get x plus 1 all squares over 2. And of course, it's going to be times my original question, times e raised to the x minus 1 over x plus 1 plus c. Are there any questions? Anybody agrees with me?
Yes, sir.
Yes, sir.
Mm-hmm. Thank you.
Yeah.
So what I was saying to you, Sash, this is an exercise. This topic is an exercise for me to refresh your differentiation. And I can give you questions to differentiate. I can give you questions on the chain rule, the product rule, the quotient rule in this aspect of it. So just be mindful of it and just get yourselves prepared for what is to come. Anything can happen. I don't know what they will send, but I want to make sure that I fully have you guys prepared for the exam. And I think we're doing a darn good job if you were to ask me so far. I just have 2 more topics that are left. On Thursday, I may not be able to start the other topic tonight because I don't want to rush through in order to finish off this integration, but I know I'm not going to need all of 3 hours to finish off that. So I should be able to start the applications of differentiation and integration come Thursday of this week, all being well. And then hopefully by next week this time, I should be way inside of that. So I can touch base with the last area on Thursday next week, just before we go off, because that will be the final class for the December here, just before we go off, so we can get some of those work in, which is really not a difficult area, incidentally. Very nice area, differential equation. We call them FODE, first order differential equations. All right. So this was just a quick revision on how it is that we differentiate. Remember, when we're integrating the exponential function, what we do is to differentiate the power, reciprocate it, and multiply by the original question. That's if the original question is raised to, is the base of the original question is E, that's what we do. If the base of the question is not E, what we're going to be doing is to differentiate the function. Then we're going to find ln of the base, and then we reciprocate both of those times the original function plus C. That's all that there is to it. All right. Are there any questions regarding this? I didn't hear some people responding also. Are there any questions?
I am seeing where you do the differential, right?
Mm-hmm.
I'm kind of in the cloud.
About what? I haven't done anything new, because all I'm doing right here, Sash, is the differential of the quotient, the denominator times the differentiation of the numerator, minus the numerator times the differentiation of the denominator, all over the denominator squares. So I have not done anything new. I'm only just introducing it into an integration of the exponential form. So where you having a challenge with the differential?
I'll get it, sir. You can continue.
Right, because guess what happened now, Sash? When I differentiate a function, I am then going to reciprocate that function. So the differential of the function is going to be 2 over x plus 1 all squared. And then when I reciprocate the function, remember you have to reciprocate it here, because when I reciprocate the function now, I'm going to get x plus 1 all squares over 2. X plus 1 all squares over 2. And then remember, we arrive at the original question, because the integral of the exponential function is the exponential function itself. Yeah, man. So the only thing that we are doing is just differentiating the first part and just know so we have to flip it. That's all. Differentiate the first part and know we have to flip it.
All right.
Yeah, man. All right. Come. No, don't write. Tell me what that answer is. E to the x squared minus 7. What's the answer?
1 over 2x.
1 over 2 plus
1 over 2x e to the x squared minus 7 plus c.
Yeah, but very good. Sash, why is it 1 over 2x? I'm just stop right here. So.
Sir, my brain never reached the other part.
Yeah, man. Next on it, that was you. Very good. Krishna, you're silent. What is wrong? I want to hear from you. Talk, man. Andrew.
Yes, sir. I'm there. Yes, sir.
Okay.
Yeah, I'm there too, sir. I'm getting it. I was stuck for a little while, but I understand what was going on.
All right,
okay.
Good.
Oh,
right, nice.
Sir, did you post the last video on the YouTube?
I did, but I don't know what is happening now. But I posted. Somebody asked about some video that was not posted, and then now I'm seeing that there are 2 Calculus 1 videos in the YouTube channel that says upload fail, and I don't know what happened. And I think that was the video on the 28th of November that the person asked about, and the last video that when I uploaded it, I have 2 of them in the channel now that says fail, so I have to go and re-upload those stuff. So forgive me. I did, and I only found out that the second one, the last one that I uploaded, failed minutes before I went into class tonight. So forgive me. I'll sort it out a little later on tonight.
Yes, sir. The
Yes,
last
sir.
video,
Yeah, good man. Good man.
the last video posted was on December 2.
On December 2.
Yes, sir.
Okay.
Calculus.
December 2 was
Calculus.
December 2 was
last week Thursday, sir.
No, see Thursday. So that one went up then? I don't know. I'll check it out. All right. Very good. Very, very, very good. Very good. So by the way, before I said, so you're not seeing the last video, Charlene, for class?
The one for December 2 is showing, sir.
Oh, so the last class one is showing then?
Yes, sir.
So Thursday. Okay, so you need to double check again, Andrew. You need to double check. So maybe the second video that
Sure, no problem.
Yeah, the second video could be for my Cape class, but there are 2 videos in there that not it says video upload failed. All right, very good. So you know what is now happening? You are now able to differentiate. You're now able to integrate a function without even writing it on paper because you're doing it mentally. Very nice. E to the x squared minus 7. You're differentiating the numerator. The differential of the numerator is going to be 2x. You reciprocate that 1 over 2x. Then write back the function e to the x squared minus 7 plus c. Done. Next. All right. So I did those 4. What time is it? Okay, we have enough time. I did those 4. Let me go back and refresh something for you. Now remember.
You know, me just gonna say the basis and number.
Yeah, man. So see here now. So the number 2 is a formula for that one. So remember now, in the first one, remember, so we did write, in the back of our head, we wrote ln, but we know say ln is 1. But when the base is not e, as in egg or enough, we have to go write the ln of that base now. All right. See it here, so 1 over b times ln a, but a can't be 1. A can't be 1. All right. Let's go. So we're given a question now as 2 to the 5x. What do you think we're going to write? Tell me. No, you're not writing on anything. Just tell me. Verbalize it.
Would it be 1 over 5 and ln 2?
Mm-hmm. You can't stop there, Sash.
Sir, well,
2 to the 5x.
Very good. Sash, you keep stopping there now. At 2 times now you stop right there, Sash. The first part is correct, Sash, but you can't stop there, so.
And then what?
You have to put back the 2 to the 5x. So it's supposed to be 1 over 5 ln 2, 2 to the 5x plus c. You can't stop another something, Sasha. I have to finish it out.
Oh, okay. No problem, I keep on forget, right?
Yeah, but very good though. The 1 over the reciprocal part is correct. Proud of you for that one. All right, let me pause here. Is there someone in the class that did not see how we got number 5? Yannick, unmute for me, please, honey. You recognize it that we don't have no 5 lines to write right here, so or just a 1 line something. It's either you know it or you don't know it. A topic like this is either you know it or you don't know it. If you don't know it, you're gonna write many lines. If you know it, you just apply the formula and you'll get it. That's it. So remember now, it is 1 over the differential. Let me say this one differently. So when the base is not e as in egg, what you have to do is to differentiate the power, and then you're going to write ln of the base and reciprocate the pair of them, and then you're going to write the exponential function plus c. All right, do that one for me. Matter of fact, don't even do it. Tell me what to write. What is number 6?
All right, so it's 2 ln 3 to the 2x.
Hello. Which one you do?
X. The number 6, sir.
So you talk about 2. We're not seeing a 2 then.
Sir, 1 over 4.
Sir, 1 over 4x.
4x, yeah.
Minus 1.
ln
ln 3 times 3 to the 2x squared minus x plus 3 plus c.
Excellent. Nestor. Dr. Teacher Nestor. You seen that, honey bunches?
Yes, sir.
You seen it?
Sir, may I go see the number 5, you know?
You want to say number 5? All right, we can work to
number 5.
Very nice. We can work to number 4. Number 4 is really not bad either. Number 4 says, let me talk about number 4. Number 6. Number 6 says, I think I'm a little too comfortable outside. Number 6 says 3 to the 2x squared minus x minus 3. Remember, it not change every single time you're going to do the same something. You can look to see if the base is egg or one number. If the base is egg, you're not going to write the ln e because you don't ln e or 1. But if the base of one different number other than e, a different something other than e, the base is different, other than e, you're going to write ln of the base. So you're going to differentiate the power. When you differentiate the power, you're going to get 4x minus 1. So you know that you're going to reciprocate it, so you're going to have 1 over 4x minus 1 ln 3, which is the base, times 3 to the 2x squared minus x plus 3 plus c. That's all that there is to it. All right, watch me now. Do that for me, please. You see, I'm trying to mix them up. Do that one for me now, please. Quickly. Come on, anybody, come. E to the 7x dx.
1 over 7 to the 1 over 7 times e to the 7x plus c.
Very good. All right, let me show you the proof. Well, I don't need to show you the proof. Let us do the, number 8.
Me, sir.
Go ahead, number 8. Go ahead.
1 over 10x to the e.
1 over 10x.
10x e to 5x.
Next time I meant say it now. No. 1 over 10x times e to the 5x squared plus 1 plus c.
Sasha, you were making a mistake, and Lexon was helping you. So you're supposed to say to help Lexon. Thank you.
To the part where I make mistake, I'm going to continue.
I love it. Oh, goodness. Yes, Sasha, you're right. All right. Nobody can get this. What is the integral of e to the x?
E to the x.
Yannick, can't just leave me halfway, so continue.
Plus c.
Thank you, please. It's so easy that one was? E to the x plus c, done. You remember, sir, always.
Multiple choice question, this, sir.
I'm going to tell you, easy 1, 2, 3, something them this. Yeah, man.
Yes, sir, I should know.
All right, let's go. I don't know if I have any more for other than these, you know. Oh, yes, I do. Come, let us see if we can just finish out the class with these questions. E to the x cubed minus 4x squared plus x minus 2. Blow. The one that got long, but talk to me.
1 over 3x squared minus 8x plus 1 times e to the x cubed minus 4x squared plus x minus 2 plus c.
Excellent.
School child squared.
Very nice. No, but you see, all you need to do is to know the rule. Once you know the rule, you're good to go. And what sir did is to give you the rule and explain what the rule is saying. And that's what it is. And you are good to go. We are good to go. Very nice. Now, question, is there anyone in the class who has a difficulty with number 10? Look at it and tell me.
Yes, sir. The power too much red from up here.
I'd agree with you. I'd agree with you. I can
You
run
know,
run out
to
of.
tell you the truth, sir.
Uh-huh.
Anytime I see the E, I know what to do, you know. But you see, anytime I see the E, it's like sometimes I don't know what to do.
Okay. Don't worry about it. It comes with practice.
Yeah.
It comes with practice. It comes with practice. I ran out of ideas when I was preparing this for you. And I said, sure, yeah, just write one long polynomial. Yeah, I can't bother. But it worked out. All right, come, let's go. Aviana. Aviana, you're not talking to me?
Sorry, I want to go on in and me answer the question, but my mic is muted.
All right, then cool. Nice.
Keep your mic unmute to talk now.
Very nice. I'm loving it. All right. Uh-oh. Who can do that quickly?
Aviana won that, sir.
Okay, Aviana, your classmate voted you in. Come, Aviana, come talk to teacher. Don't fail me, no, Aviana. Come talk to teacher. The integral of 8 to the 2x plus c. I mean dx. She can't find the unmute button. Come, somebody talk to me.
1 over 16x ln 8 to the 8 to the 2x plus c.
Hold on, are we get 16x from him?
So I'm with a girl.
No, man. Try it again. Is she correct with the 16x?
No, sir.
No, sir.
What is it? Somebody help her with
Aviana.
Come, Aviana, come again. Your classmate, is your classmate them look out for you? Come again, Aviana.
To our x first.
You remember the first thing we do, Aviana, is to differentiate the power. When you differentiate the power, Aviana, what you get?
2.
Very good. And then is a base E or is a different number?
It's a number.
Good. So you're gonna find ln of that number, don't?
Yes, sir.
All right. So come, tell me the answer now. So you know that the differential is 2. So what are we gonna get for the answer?
So 1 over 2 ln 8 plus c.
You miss out something, man. Remember, so the differential of e to the x is e to the x. So 1 over 2 ln 8, yeah? Times what?
8 to the 2x squared, 8 to the 2x plus c.
Very nice.
Good
Very
girl.
nice. Very nice. I mean by your figures. Very nice. Very nice. All right. So, you know, the class is not exclusionary. I need to get all of it involved. Let me see now. I need to hear someone who is not following. Oh Lord, where's my come? Somebody here. And who should I call upon? Eeny, meeny, miny, moe. Eeny, meeny, miny, moe. Eeny, meeny, miny, moe. Let me call up on Ramesh. Ramesh. What's the answer? Okay. I'm not there. Let me call upon Zidane. Talk to me.
Sir, 1 over 3 times ln 10 times 10 to the 3x plus c.
All right. I know what you're talking about, but you never say it right. But we know what you're talking about. So say it again. Say it again. You're correct, you know, but you never say it right. But me know, as a teacher, me know what you mean. Say it one more time.
1 over 3 times ln 10 multiplied by 10 raised to 3x plus c.
Okay. Very good, sir. Very good. What you said was anybody in Was I correct in telling him that he said something wrong? Anybody recognize what he said?
Yes, sir.
What him say?
So him said 3 times ln 10.
Right. So it's not times ln 10. Because if it was ln times ln 10, it would have been ln 10 over 3. So I know what you meant, but you said it incorrectly. But yes, very good. So it's going to be, remember, you're differentiating the power, and the differential of the power is going to be 3, and you're going to find ln of the base, and the base is 10. So it's going to be 3 ln 10 that you're going to reciprocate. So you're going to get 1 over 3 ln 10, and then you write back the function plus c. Very nice. Very nice. Very nice. And guess what? The class is finished because the integration by substitution I'm not going to do tonight again. But I don't have time to do it tonight. So you tell me now. This is very good. I cannot. Matter of fact, let me make up some out of my head I have 4 minutes and I can't give the 4 minutes because you're doing so well that I'm so proud of you. Let me, you know what? School challenge quiz. Chedi Ann, come, unmute, your turn. Come, Chedi, quickly, unmute, quickly, Chedi. All right, Chedi not there. All right. Krishna, your turn, unmute, please.
Sir, I'm here.
Okay, you're here now. All right, Chedi. So I'm going to ask you the question. Your classmates will tell you at the end if you're right or wrong. Integrate for me. 5.
Wait, sir, wait. I'm going to get my pen.
What's your, so I'm not class today. Your lounge.
Sir, don't do it like that. Go ahead. You said go ahead, sir.
All right. So the integral of 5 raised to the 3x dx. The integral of 5 raised to the 3x dx. What's the answer?
Sir, hold on, Mama.
So all of you do it, and then you will check and tell me if Chedi is right. The integral of 5, I say it out of my head, so you have to work with 5 raised to the 3x dx.
Of 5 raised to the 3x. Sir, that is 1 over 3, 5 to the ln raised to 3x plus c.
Okay, is she correct?
No, sir.
You feel wrong, it's true.
Yeah, it feels wrong, it's true. Try it again. So it's 5 raised to the 3x dx. Come. You started off correctly, do you know? 1 over 3.
Yeah, 1 over 3. Which one am I wrong, sir?
You know, tell you, who you have to which part you're wrong? I'm here to do the question. Come, do the question.
1 over 3.
Mm-hmm.
ln 5.
Mm-hmm.
To the, what must I say the first time? 3x?
No, set times. What's the times?
Set times?
Mm-hmm.
Oh, times 3x?
Times the question, times 5 to the 3x.
Oh, yeah. So I try to write it funny, I type it. So sometimes more visual, yeah. All right, so let me start over.
Mm-hmm.
1, no?
Yeah, man, that's a start over. Go ahead.
Okay, so it's 1 over 3
mm-hmm.
ln
mm-hmm.
5
mm-hmm.
times
mm-hmm.
5 raised
mm-hmm.
to 3x plus c.
Mm-hmm. Very good. Nice.
Mm-hmm.
Very nice. Very, very nice. Okay, and okay, so it's now 7 o'clock. All right. Very good. Let me just tell you something, what you may not know. You guys did very well tonight. At first, you were a little hesitant about the laws, the rules, but having worked the questions repeatedly, you felt comfortable to do some mental integration. What I'm going to ask you to do is just to concretize those 2 formulas. It's really one formula, but one of them is when the base is E, and the other one when it is not E. and everything else works. Yeah. It's the same formula. It's the same thing that we're doing. It's just that when the base is e, ln e is equals to 1. So the formula is further reduced. So it's one formula. But when the base is e, the function is reduced somewhat because ln e is 1. But it's the same formula we're using. When we're integrating an exponential function, it's going to be 1 over the differential of the function times ln of the base times the original function. But the ln of the base is e, ln of the base is going to be 1. All right. So you did very well. On Thursday, I will, once if I can finish making some more notes on integration by substitution, I will do that with you. I'll do that with you on Thursday. This I'm not going to take a lot of time doing.
That one looks serious.
It looks serious, but it really isn't. It's all of them ugly something over here. So we look on right. So with the 6x times 3x squared minus 5. Yeah, that one looks serious. But once I make a substitution,
product rule that you're going to do, sir.
Yeah, but you see, except that you don't have a product rule for the.
We have a product. Lower limits or something,
Something, yeah. But you see, we're not going to use a product rule because we don't have a product rule for integration. What we have is like integration by parts. And that is not on your syllabus. That's when you do calculus 3 and calculus 4. All right.
That's so past my grade, sir.
So yeah, so I'm going to teach you the substitution method that will make life so much easier should in case you get a question like this. But so far, you guys have been doing very well. Proud of you. Want to go do some more work? Talk to you on Thursday, all being well. Remember to be safe, wear your mask, social distance, sanitize. Have a good one.
Sir.
Yes, Papa.
One moment before you go.
Yeah.
Sir.
Go ahead, Rami.
Yes.
Sorry,
Cameron.
Andrew, sorry.
Last time I heard about Edicasoft, you had some things they need to modify before it starts completed.
And I said to you, go ahead because the modification won't take effect until the course is finished when I shut it down.
Okay.
Right.
Okay,
so just go ahead. Go ahead and continue. I will rescale those grades. The ones that contain the trigonometric ratios, I will rescale those.
Okay, sir. Thank you.
All right, no problem. Have a good one, guys.
Same to you.